Okay, so these are going to be our notes on circular motion. Let me get the pen there. Okay, so we're going to start kind of something different. We've been looking at linear speed and motion, and now we're going to look at something that's a circular motion, that's a circle. Or another way to think about it is it's something that goes around a central axis. And the motion is very similar to what we've been talking about. You can measure acceleration, you can measure speed, and so on. Many of the same things, and this is just moving around the axis here. Many of the same things we measured with linear motion, you can measure with circular motion. And really we have four measurements we can take. One is tangential speed, the other one is centripetal acceleration. Another one is tangential acceleration, and then centripetal force. So we can look at the two types of acceleration, we can measure speed, but we can also determine the force that causes that motion as well. So if we look at the first one here, tangential speed, this is just the speed of an object at any point along the circular path. Okay, so let's just imagine we had a CD, it's in your, or a DVD. Let me redo that. It's not very circular, but do your best to imagine that it is. And just imagine you have a DVD, you put it in there, you want to play either Xbox or whatever it is, and you place that in there, and just imagine there was a little bug on there. Okay. And this bug, as you push the CD in and begin to play, this CD is going to start to turn, right, really fast. Okay, and if you're a bug on here, you're moving around circular, and you have a certain speed. And the way we measure speed of an object moving in a circle is something called tangential speed. So we could measure any point along here for, say, this bug here, and we could say he's moving at a straight line like this, and we could figure out what his speed would be at any given point. So if he was over here, after he moves, he's still moving in a straight line. Like if we just took him out of that circular path, he would begin moving in a straight line away from that circular motion, and that's tangential speed. Okay, and this depends on how far away it is from the radius, okay, or from the center, really the axis. Okay, and when it says it depends on the radius, that is how far it is from the center. So if we measured this right here to the bug, that would be the radius right here, R1. But then if we moved him way out here, this would be R2, radius 2. And if you think about it, for this bug to move around here from this radius 1, he has to move a certain distance, as this CD is turning. Okay, but if you're this one, it has to move a greater distance. Let's just imagine that here. So if we redrew this, I'll give you an idea of this. So if we redrew this circle, not sure how good I can do that, I'll do my best. And then we have a bug right here, and a bug right here, two different bugs. And then this one goes around the center, and it moves a certain distance as it goes one revolution around. And then the other one has to go that far. Okay, but if you could see inside the DVD player and see this thing turning, you would see that these bugs stay in line with each other. So that what that kind of suggests or means is this bug has to move a little faster than the bug on the inside, because he has to cover the same distance, or he has to cover the larger distance in the same amount of time. Okay, so this guy would have a larger tangential speed than this guy. just because he has to go faster to keep up with this bug. And because if you looked at it, they would be in the same spot all the time, but this section has to move faster than that. Okay, and that's kind of tangential speed. It's just a speed. If we measured this bug, its speed any time as it's moving along here, then that would be the tangential speed. And then there's also a term that goes with it, uniform circular motion, and this means that it doesn't change, no change. And that's often true in objects that are turning on a circular path. So the DVD is generally always turning the same speed as it's being read. So that means if you were a bug on here and the circular motion never changes, so that means your speed never changes and you have uniform circular motion. Okay, there's an equation for this. This tangential velocity, you square it, it's equal to the acceleration, centripetal acceleration, times the radius. Okay, so let's rewrite that. Tangential velocity I'm just going to call it tangential V equals centripetal, I'm going to call it cent acceleration times the radius. That's your equation right there. Okay, so that's kind of tangential speed. Look at the next thing. There's really two types of acceleration when you're dealing with circular motion, and that's because of the shape. You have the normal acceleration that you think of, like if an object is either speeding up or slowing down. That's a normal acceleration that we think of, and that for this circular motion, that's going to be tangential acceleration. So as we have this DVD, it's not a very good circle, but a bug, he's moving here at a certain tangential speed, and then the CD is slowing down for you to shut it off, and it gets slower and slower. Okay, like that. That's tangential acceleration. And this is, you measure just the same way, a straight line, change in velocity over time, and you would know the acceleration. But there's a different one, and that's centripetal acceleration. And this is acceleration due to a change in position. Okay, so as this object moves around, say it's a bug, it actually has this behavior where it's doing two things. It's moving like this tangential, but it's also moving towards the center. And in the end, that gives us this vector that kind of moves around. So this is moving out like this, but it's also moving towards the center. So it gives us this kind of motion in the end, and just keeps doing this all the way around. Okay, but see, we're moving a certain, we have speed this direction, and now we have speed this direction. So that's changing. Okay, and acceleration can be that too. So even if this object is moving at the same speed, it does not change, and tangential speed doesn't change, which means constant velocity. There can still be an acceleration because it's changing its position. Okay, so for any object that's rotating around an axis, it can have tangential acceleration, a change in speed as we know it, but it can also have centripetal acceleration, which is a change in speed due to a change in position. So like if you're driving to Anchorage, and you're driving, and you're going to get off on Muldoon Road, okay, and you're going to do a little cloverleaf here, and you're in your car, and as you go around this little thing here, you're kind of changing position of the car. And even if you keep the speed the same, you're kind of going this direction, and then you're going this direction, and then you're going this direction, and then you get on Muldoon or whatever, and so on. But that's centripetal acceleration. Even though your car's speed isn't changing, the direction is, and that's called centripetal acceleration. Any object that's going around an axis, you know, even if you had like a slingshot or something and you're twirling a rock around, it's a constantly changing position. It's not really necessarily changing speed, but it's changing position, and we call that centripetal acceleration. And then this one just change in speed, what we're used to calculating. And then the last thing we have to worry about is centripetal force. And centripetal force kind of helps us explain what happens in circular motion. So if again we go back to this DVD, or let's even, yeah, we'll go with that, DVD. So like this, okay. And then so we have this thing turning, okay, this CD, and there's these forces at work here. And a good way to understand it, really, maybe a better way than I'm doing here, is think of if you had a ball, you tied a string to it, and you stood there, and you twirled it around. I know that's not the greatest picture here. Okay, and when you twirled this around, it would make this circular path, right? And you think about what the ball's doing, and it kind of helps explain the acceleration and everything. So if you got this circular path here, this ball is moving in two directions. It's moving, it wants to go a tangential direction, okay, and then but it also at the same time it has this motion here, okay. So what causes this difference? So if you let the ball go, you can actually prove this is happening, because if you swing this ball around, you let it go, it's going to go straight out this direction wherever you let it go. So if you let it go here, the ball will go straight out. If you let it go here, it will go straight out. Okay, so you know, absence in making this go in a circle, if you let the ball go at any time, it's going to make this straight line path. Okay, so centripetal force is talking about that force that you have to apply to this to cause it to have this circular motion, and that's something that an object applies. The DVD, as the DVD player applies to cause this to turn a circular motion. If you have a ball on a string, you're applying a force to the center that causes this to continually move back to you. Okay, but because there's other forces working here, and if you apply a strong enough centripetal force, it will come back to you and hit you. But if you apply the right centripetal force, it'll cause this circular motion. And then, and you think about the forces that are acting on this, you have this force that you're applying, but at the same time there's another force that will cause this straight line motion, okay, and also will cause this to fall to the ground, and that is gravity. Okay, the Earth is applying a gravity to the string, and if we let it go, eventually it'll fall to the ground, right? But also, you apply the force that causes it to remain in this circular path, okay? And in the end, you have all these forces that are interacting to cause this circular motion, okay? We call that centripetal force, okay? So that causes that circular motion. So it's just force that causes circular motion. It's a force directed towards the center. So really in this CD, we have a force that's coming back to the center, trying to bring this thing back to the center. Then you have all these other forces, gravity and a force applied, that causes this to do the circular motion. But the equation we have here, and I'm going to erase all this junk, the equation we have here is F of C equals mv squared, tangential velocity squared, divided by r. Let's just write this out. So this is centripetal. And let's actually do it a different way here. So centripetal centripetal force equals, let's make this a little smaller. Come on. Put this over here, centripetal force equals, let's go back here, centripetal force, if I can get this to highlight, one more time, let's go a little smaller here, okay. This is equal to, this is F of C, equals the mass times tangential velocity, and you're going to square that, and that's going to be divided by the radius. So for instance, if we have a ball on a string and we're twirling it around, if we figure out how far away it is from you, that's the radius, and then we figure out what is the tangential velocity, okay, and we could use our other equation if we went back here. We would just say the acceleration, centripetal acceleration times the radius, that would be our velocity, tangential velocity, divide that by the radius, and that will give us the force we need to apply to keep that ball in circular motion. So these are your 4 basic terms. Make sure you have these annotated, turn this into me, and you'll be good. And let me know if you have any questions. Make sure you review these. Also complete the other homework to give you a really good understanding of what these terms mean. And talk to you later.